Jamie Pope is with JMS Southeast.
All right, hey guys, like Nick was saying, I'm the sales manager for JMS and starting 28 years with JMS. So it's been around for a little bit of time and been in the current position right at 20 years. Anyway, JMS is manufacturer of thermocouples, RTDs, and Thermowells. And that, as Nick indicated, Statesville Process is the rep for JMS in the Carolinas, but JMS also has 13 or 14 other rep companies throughout the United States that sell our product as well. Just real quickly, one of my duties is I go out and travel with the sales guys, calling on customers, doing lunch and learns and things like that. So if you may or may not be aware of that, but you utilize us as a tool to help educate with, in your own company and or customers that you may have. I'm not sure of all the customer bases online today, but some may be EPC, some may be the end user, some may be I don't know. So anyway, so use us as much as you feel. Glad to come out and make sales calls with anybody or any type of special application they may need. I'm going to I'm going to share my screen just sometimes I guess really what I want to start with first is thermocouples. This is typically our catalog page. You can pretty much have a gazillion different ways to make a thermocouple. And not sure if everybody knows how thermocouples are made, but hopefully you can, I don't know if you can, this is MgO material, thermocouples, a 3/8 OD piece of material. And hopefully everyone can see there's two wires inside there. May or may not be able to. But anyway, there's two conductors inside here. So if this is a type K thermocouple, there'd be a chromale and alumale leg in there. There's two wires, so this is a single thermocouple. If it was a dual thermocouple, there'd be 4 wires inside that. So whatever the if it's type J, be iron and Constantine. So typically, whatever the diameter calls for when you go to make a thermocouple is that you have to strip off this outer edge, and you'll have 2 wires sticking up like this. And this is what's going to become your junction. So you can have a grounded junction or an ungrounded junction. And hopefully you can, not sure, hopefully you can see these two different, this is a grounded junction and over here is an ungrounded junction. And a lot of times when customers call in to JMS, they all say, well, why do I need, what's the difference between an ungrounded and grounded? Or why do I need one versus the other? Well, there's several reasons, but mainly a grounded junction is where the wires are welded to the tube casing itself, and it's for a quick response time. An ungrounded junction is a little bit slower response time, but if you got a lot of electrical noise in your application area, it's going to pick up that noise and run interference through the thermocouple. Now, sometimes response time is not critical in some applications, and maybe 3.8 seconds versus 1.6 seconds is not real critical. At some folks it is. So it just depends on what it calls for. I know you probably won't, hope you can be able to see that, but as this is a 3/8 OD piece of material that's 2 wires inside of it, the one beside of it is an 040, and there's 2 wires inside of that. So hopefully I hope you can see that, because it's extremely small. And we make thermocouples down to an 010 with 2 wires inside of that. It's like putting, you imagine 2 hairs on your head inside of a piece of sheath material, and you have to do a junction on that. So there's a wide range of where these thermocouples can be used at. When we design thermocouples, there's 2 critical things to making a sensor. And it's always knowing what the tip temperature is going to be, whether it's a thermocouple on RTD or whether it's or at the transition area. And so typically, these wires run all the way down this tube where your junction is. And a lot of times you will have there'll be a plug on the end of this particular thermocouple. There could be a remote mounted head on the end of the thermocouple. But whatever the case may be, a lot of times we have to transition the wires coming out of this tube to a terminal block or to 20 feet, 75 feet of thermocouple wire. And it's real critical to know what this temperature is going to be right here, because if we're splicing wire into this, we have to seal this junction, this transition area off. So if this transition, a lot of times people say, well, it's going to get 1700 degrees. My tip temperature is 1700 degrees Fahrenheit, but I want to go ahead and seal that, make sure it's sealed off for 1700, but this may not be in the hot zone. This may be outside your furnace wall. And a lot of times people think, you know, the higher the potting compound is, the better it is, but actually it's worse, because if this is in a low temperature environment, say under 300 to 400 degrees Fahrenheit, you want that potted for, that's more of a moisture environment type area. Real critical that this get potted with the correct temperature that it's going to see. So sometimes more is not better. And when our inside sales staff and our sales reps will ask questions, when people call in, we ask a lot of questions about thermocouples. You know, what it goes into making a part number, because it's very critical that you get the correct thermocouple for your process condition. And that's just one of the applications, one of the things that's critical on this type of thermocouple. Same thing with RTD, and I'll get into that in just a minute. If anybody has any questions, they can blurt it out, or if there's a chat box, you can ask a question, things like that. You know, it's really hard to make thermocouples exciting, but, you know, it's been around for, you know, many, many years, the technology has. So one way what JMS wants to do is to try to make a better thermocouple, okay? And let's just say, for instance, a well pad type thermocouple. This is a standard well pad thermocouple. It's got a 1/4 inch OD, it's got a 1 by 1/8 inch well pad, and the junction sits on top. It's kind of basically an old school type design. A lot of power plants use it all the time. It's a good product. But what happens with this thing is there's several ways this thing can fail. One, somebody can cut it in the field when they go to install it. A lot of times people aren't used to, these aren't major industrial, this is not a major industrial size type apparatus. So you don't have to weld very much to this thing to tack it to a piece of tubing or to a pipe. But a lot of those guys out in the field are like monsters. You know, they're going to add a lot of heat to it, and a lot of times they can overheat this junction by welding it to it and destroy the thermocouple before it's even installed. So what JMS did years ago, we came up with a removable design thermocouple. This is what actually gets welded to your pipe, and this is what does the measuring junction. So why don't you say, you're just tacking this to a piece of pipe, you go to put this in, you're welding this to your pipe. Your thermocouple is not even in the picture, okay? So you can't destroy the thermocouple by overheating it. You're gonna weld this to it. Another good thing is that most people like to weld similar metals together.
Hey, Jamie.
Yes, sir.
Real quick, would you mind, when you're showing us that, would you mind stop sharing the screen so that we can see you, larger image? Thanks, man.
Yeah. All right, is that better? All right, so we just had a customer who ordered 25 or 30 of these, and he actually ordered this material, the shoe, in F22 material, because that's what his pipe is made out of, and he ordered the foot out of Inconel 600 because it's going to about 1790 Fahrenheit. Okay, he wanted to weld similar metals, which is great, and he ordered this in a less less expensive material than the F22. We made this dummy proof because, as you can see, hopefully there's a Carter pin hole here, and there's a hole in the top side of the thermocouple. So you slide it in, the junction is on the bottom. Whereas on this design, your junction is on the top. On this design, these wires run all the way down. We bend them at 90 degrees. So when you're doing your measurement, your thermocouple junction is laying against the pipe. It's not laying on top. Much quicker response time. As in this acts as a heat shield. A lot of times there's, large flames are going past these thermocouples. You don't want to take the flame temperature. You're trying to take the surface of the pipe itself. That's what they wanted to monitor in these applications. So this acts as a heat shield. But the great advantage to this, and there's several, as I mentioned already, is that when you've got to go replace one of these thermocouples, if you have this type design, you've got to get a certified technician in there to cut this off, resurface your pipe so you can put another one back on. If this sensor were to go bad, get cut, or they just replace them year after year like a lot of folks do, they just got to pull this out. This portion stays on the pipe. So their cost savings year after year is tremendous. And not having to get somebody to come out there to resurface your tube is a huge expense and a lot of time to get involved in doing that type thing. So that's something that we try to like I said, hard to make them exciting, but it's easy. And what we try to do is make them better for the technicians in the field that they're working with. Another design, something that is big with their oil and gas or oil refineries. This is typically a remote mounted thermocouple. Okay, it's got yellow flex on it. We color code flex to help guys in the field know that this is a type K thermocouple. There's a lot of folks out there that don't understand that each thermocouple is color coordinate. I mean, it's color coded. For type K, it's yellow and red. For type J, it's red and white. For type T, it's purple and blue and red. So it's real critical folks out there know that kind of thing. So this is something else. Typically, we would just have black flex on everything, and which we can still do. But just let you know that JMS likes to take the next step and color code something like this to help people in the field. So we have yellow for type K, orange for type N, purple for type E, black for type J. Currently, we have a customer who had a special request that they order type Ks and type Js all the time for their refinery. And instead of having black for type J, they're having us order red. And all their type J thermocouples are going to have red coated Teflon flex on it. If somebody wants it purple with white dots on it, we'll do that. So that's one of the things I'm trying to my point across to folks is that, JMS is not just a temperature sensor manufacturer. Wants to try to get one sale and going. We want to build a relationship with everyone and, dig deeper into plants and show you all what we can do. Majority of our business are, what we would consider a vanilla type sensor, a Thermowell, Springloaded into this is we do this all the time, and it's great, and it's for whatever process. But I'm going to share my screen real quick here again. That we do things like this as well that you may or may not be aware of. So in our catalog, if you're familiar with it, there's a section and there's an X in each section, which means something special. And being ISO certified, if we have more than 2 X's in a part number, we have to do a drawing for our customer, and they have to sign off on it and approve it. Now, something like this definitely cannot be made out of the catalog with a part number, but just kind of shows you the things that we do other than just make a spring-loaded thermocouple. These are heavily engineered type products. So the point I'm trying to make here again is, if you can dream it, we're going to make it for you. And that So please, you know, just think about that. So here's just some samples of some drawings that we've done, some specialty items over the years. I mean, they're not oddball, but they're just really special. And a lot of design, a lot of work goes into these drawings, and it really, you know, helps us tie into that customer. So, like I said, if you got a application you think's odd, we don't think it's odd. We don't like saying no to customers, and that we'll do anything we can to, you know, promote that and get that product that you want. So I'll just kind of go through these real quick. So as you can see, there's a lot of special designs, and it may not be this type thermocouple you need. We'll do a drawing for a standard, you know, a standard spring-loaded thermocouple and that kind of thing. Another thing is that talking about the well pad, which are surface temperature sensors. This is a magnet type thermocouple we came up with. Air Products years ago could not use a well pad. They could not weld onto a pipe, take skin temperature, because it was an explosion proof environment. And so we have came up with these magnet type thermocouples that are rated. We have different magnets rated for different temperature applications, but it's a great product. This is just a sample. It's a little handheld, you know, device. This only has about 6 inches lead wire, but typically they have 50 feet or 100 feet of lead wire. We've done special where we come up and put a head on it, kind of thing. It just kind of shows you the strength of these things. I mean, holding this above this cast iron head above my laptop, and you know, it's a good product. And you can do a quick temperature. A lot of times people will get these that have a mini plug on and go around checking for hot spots all around their plant, kind of thing. And it's a great tool. Just don't get it too close to your cell phone or your laptop. Let me jump over to biggest tools right now we have out there is something called Sweety Cow. It's a Thermowell design guide that will allow you to design a Thermowell to hold up in your process. And you know, folks that are on currently right now with us, I mean, you may or may not, you may have already be a Sweety Cow user, you may not have any idea what it is, but if you just go to our website, which is at www.jms-se.com, and click on, you'll see a blurb down here that talks about, you know, weight frequency calculations and sign up for Sweety Cow. So if you're not a member, go on the website, click that thing. This is a free tool to anybody. It'll send an email notification to myself, to our president, Mitch Johnson, and to another inside salesperson. And as long as you use your company email address, you're good to go. We do not accept people. We turn people away with Gmail accounts and Yahoo accounts and things like that. So anyway, just keep that in mind. So I'm gonna go ahead and just log on to it. And it's all password protected. So if John at ABC Company can't see what Joe ABC Company, unless they can't see each other's work unless they, you know, share their password type stuff. So I'll just sign in. So anyway, so go to the website, scroll down, you'll see the Swifty Cow. Click that, and that's what I was talking about. We'll send myself and Mitch, another inside salesperson, a notification that, you know, Joe's wanting to sign up for Sweety Cow, and so long as he uses his company email address, he's good to go. So log on, sign in. Take just a minute. So this is my Swifty Cow account. Lots of calculations over the period of time. Anyway, this is one I did yesterday with one of our reps, and just kind of just pull it up. But you've got different process variables here. So Thermowell calculation is what we'd get it to. So click on it and go to edit it, and it'll pull up my calculation that I did. But for the most part, everything, if people are, I'd say, pretty self-explanatory. But anyway, so typically this would be blank, and reason I went ahead and pulled this one up because it can be time, I think, via this route right now. So that's why I went ahead and pulled up the current one. But anyway, so you choose the kind of well you want for your design, where you want flange, threaded, socket well, weld-in, sanitary, whatever the case may be. In this case, I chose a flange, and when you choose whichever one you go with, it'll default to certain standards already. So this default to 1.5 inch flange, 150 pound raised face, 316 stainless steel. You have options of full penetration, or if you need a non-destructive test done on it, you have those kind of options. You basically put in what you want here, whether you want a U dimension of 7 inches, 13, or other. If you click other, you put in, basically put in what you want. So that's all the, that's like your dream, and that's what you want to go in your process. And where it counts is you go to your process conditions. And this is where it calculates if this U dimension is going to hold up within your process conditions. Because once you stick this Thermowell into a process, you've got, as your fluid goes past this shank, it creates a wake frequency. And as that frequency matches up to the natural frequency of this thing, this shank can break off. So by the PTC 19.3 test code, the customer, this is what the customer has to give to JMS in order to do the calculations. We can do calculations for you, or you can do them yourself. It's kind of your call to make. We don't have a problem doing them for you at all. So anyway, so you'll go in here and you'll name this thing, and then you got to put in all your variables, whether you're in a steam application, a liquid, a gas, or something other. In this particular, I had steam. You choose what size pipe it's going into. All the standard pipe sizes are in here. Then you've got schedules to pick out and that kind of stuff. So you've got to, whatever you customers have to give this to us. And then you got to put your flow, your temperature, and your pressure. So, once you do all that, that's where this calculation here becomes key in doing so. So it's very critical that these conditions that you give us or you do yourself they're accurate, because it is the key to making this thing pass your calculation. When you're doing this, if you were to have a fail, if one of these stresses or limits or frequencies fail based on your variables you put in, you may have to come down here and you may have to make the tip diameter, from 5/8 to 7/8, or you may make this Q dimension, from 1 1/16 up to 1 1/4, whatever the case may be. It's kind of, if you have something that fails, it's just kind of playing around with it to see what's going to get it to pass, and there could be several things to get it to pass. It's just kind of a trial and error to get that, and that's why it's so important that your process conditions are accurate.
Jamie, can I break in for just a moment? We got a question down in the chat. I don't know if you've got that visible on your screen at the moment.
I don't.
All right. The question is for flow. Is it the max flow or the flow at max velocity?
It's the max flow velocity. So basically, people are putting their maximum conditions in there that this is going to see. Now, a lot of times people overshoot that, like go for the extreme high. And there have been cases where we've had, the they've had to go back and actually recalculate that, because sometimes there have been thermowells that you just can't get to pass. And that's when, whatever, and most of those are, seem like they're in high pressure, high steam application type stuff. Yeah, I don't see those questions pop up. So Bob, if you let me know, I don't see that with my.
Will do. I'll keep an eye on them.
All right. So doing this calculation, after you do that, you can go over here and you can make a sensor match that, and it can be a thermocouple, it can be an RTD, whatever the case. You can make it ungrounded, grounding. It's just a great tool. After you do that, you can this one particular. Now you have to, if you've got one Thermowell application, I'm sorry, if you've got like 10 different Thermowell applications in your plant, and all of them have the same process variables, you can just do one calculation, list all your tags underneath that. But if you've got multiple variables within those process conditions, you have to do separate calculations themselves. So keep that in mind as well. Currently, our customers don't have this capability, but JMS does, and we're in the process of updating this where customers will be able to do this. But if you want us to, we can take this and convert this to a drawing, a quick drawing for you to have. Maybe your client needs to see it, or whoever the case may be, but it'll pop up. It's self-explanatory. So here's just, it's just a fairly generic drawing. It's a little different than the other drawings I showed you a minute ago. But, shows you, sometimes people have a hard time seeing what our part numbers can be very lengthy. And it sometimes just folks, pictures worth 1,000 words. And if you need a drawings, this is very easy to do this by. You can go over and you put project name, you can put whatever information you want this. Of course, this has JMS's name on it, but it would have your name on it, that kind of thing. So it's just a great tool to have. And also, if you don't, you can convert it to a data sheet as well for your records, and as far as having OEM manuals and stuff like that, for spare parts lists and stuff. So you can create a nice a data sheet here. And it would, of course, if you had tag numbers, it would have tag numbers lists and things like that. But when you're doing these calculations, it's my sworn duty to tell you to hit this red quote button. And what that does is when you do that calculation, if you hit that quote button, it'll send an email to the inside salesperson that's dedicated to your region. So if you're in South Carolina, that would be Courtney Brown. So if you hit that quote button, Courtney and I get copied on a request saying, Joe at ABC Company is requesting a price for this Thermowell and thermocouple, or just Thermowell. And so it's we try to make it easy for our customers to communicate what they want and get it back to them in a timely manner. And so please don't forget about that quote button. And there's people all over the globe that use Sweety Cow, and the percentage of quotes we get from that are really, really low. And we didn't design, we certainly hope people use this tool and request quotes from us. But it was a tool out there that we want to build a relationship, and that's what JMS and Statesville Process and other reps, that's what we try to do. We want to build a relationship between us and you guys. We're not just in it for a quick sale, so please. And one other quick thing, if you like for the EPCs, like these are individual calculations, but we do have a project side. So where if you've got, we've got customers that may do 200 to 300 different calculations, and they don't, and out of those 200 wells, maybe there's 30 different calculations. But we have this project side spreadsheet that we can send to you, where you just have to upload all your variables into a spreadsheet, and it will actually calculate all individual calculations for you, and it'll give it to you in this format and tell you what's passed and what doesn't pass, tag numbers, and you click on these things, if you click on these links, it'll actually show you the calculation kind of thing. So it really is a tremendous tool, and please don't use it for those folks that run into these type situations. It's out there for you. It's a free tool. We just ask you to give us a thought when it comes to request quote, that kind of thing. Also, I had to get out of that to show you this one. Y'all see this nozzle looking screen right now? You see this now? The nozzle and a...
Yes.
Okay. This is another service that JMS can provide to you that we're starting to do more of. We have a refinery that has asked us to come up and measure the nozzle, verify the nozzle wall thickness of their application. They've got like 360 units on site, and they're getting ready to redo. They've got a shutdown coming up, and the plant is a very old refinery, and what they're worried is what they have discovered in the past is that they're ordering Thermowells. For example, this one with a 1.75 Q dimension, and they go to put it in their nozzle, and they think that their nozzle is a Schedule 80 pipe, which has an ID of 1.93. When in actuality, they ordered a lot of wells and find out that their nozzles are Schedule 160, which has an ID of 1.689, which this Thermowell does not fit. And that's something else that we can do, that we're going to do this as soon as this virus thing is, where people can get back on site. Right now it's delayed to June 1st. But what we were going to do is go out, and we have a ultrasonic piece of equipment, which you can take the diameter of the pipe. You can find out that very easily. All pipe diameters have standard, whatever wall thickness have the standard IDs. We just have to find out what wall thickness, that they're either Schedule 80s or Schedules 160s. And based off of that, we'll take this and run with it and do all these calculations. So, JMS in the past has not been a lot of on-site type things as far as coming out making sales calls, say, yeah, this is what we need to do here. But this is actually a 2-week process, because there's, like I said, between 350 and 360 spots we've got to test, and they, scaffolding's up and things like that. And we have to go through the training process of their, the company's procedures and things like that before we can do that. But just another option out there for you. So if you need something like that, that's what we're there to provide. If any of you guys, any of the customers that are on this that have are like OEM type customers, where you buy the same product, month after month, this is something we have as a RPO, as a stocking program. So for easy math, let's say you did 100 and 300 pieces, 100 pieces a month. We build a min max of 100. Minimum of 100, set a max of 300. We build 300 pieces at a time. Customers takes releases. When it gets below 100 pieces, we initially do a production order to build the next quarter year supply. So, something else that we try to provide to folks, that instead of trying to, remember to order or set blanket orders for a whole year, there's RPOs that we can do. If you do a blanket order, typically you're tied to it for the whole year. Say if it was 1,200 pieces, This way you have flexibility. You may want to change a part 3 months down the road, or maybe not. And it's nothing that requires a purchase order. It just has to have a signed contract. And so anyway, another service that we try to push to folks, that what we're trying to build is relationships and show you what all we can do. Oh, and everybody see, Nick, you see this in my hand?
Yeah,
can see
yeah,
it.
Okay,
Jan,
I just want to make sure you can see this.
yeah, you're good.
This is something else that we try to make things back to easy for guys in the field. This is something one of Nick's customers orders a lot of, but it is it's just a spring-loaded sensor, and nothing really exciting, but being able to, typically this would have a Thermowell, but I don't have my Thermowell with me. Typically, if you got to replace a sensor, we try to make this easy for guys to do. Typically, you have your Thermowell here. You wouldn't have to take a wrench and undo this fitting, and it could be under high pressure, and you could get a wrench on your Thermowell and cause a little bit bigger of a problem. So another way of formatting to having a customer do something very simple is replacing a sensor, something like this. Symbol in our product, this is a 4-wire RTD. It could be a dual 4-wire. This is an explosion-proof head. We have it in a general purpose head. So once again, it's just something else we try to push to, to show folks what, we try to help them as much as we can in the field when it goes to replacing things. And one last thing. Every time I go out and I talk to customers, this is the last thing I tell them about, and it's our Swifty Sensor Service. And a lot of you probably already know about it, but maybe some of you don't, and I don't like not going without talking about it. JMS, standard lead times are 2 weeks right now, 1 week on a lot of things. But anyway, we have a crew of about 5 or 6 individuals that work on Swifty orders that are placed every day. We make everything to order. All these pieces of material I was showing you earlier, all that stock stuff. We don't have a completed sensor sitting on the shelf waiting for you to order, like a 6-inch or a 12-inch. Everything is made to order. But we have a crew that work for the RTD, whatever the case may be, and it's a 24-hour turnaround time that you call up and you get BJ and say, hey, I need a thermocouple. I need it out today. Can you do that? And say, well, sure we can. So long as it's standard materials, 316 Inconel. We have Hassel C, 304, all the type J, type K, type, all the standard calibrations of thermocouples and RTDs. If you ever need something in a quick hurry, that's what this service is for. This is a little brochure that we put into a lot of the I&C shops to let folks know, because so far this year we've had 3 things over the weekend. People come in, call in to our 800 number and get the emergency contact number and say, hey, I need some thermocouples. Can you help me out? And say, well, sure we can. So I really emphasize, put that to the test. As long as it's standard materials, we can make it in a day. We just ask the customers to ship it overnight. And one reason we do that is just kind of a qualifier, because we've had customers, say in Texas or Utah, want us to make 2 or 3 sensors and ship them out and then ship them ground. They don't get them till Friday or Monday. That's really not a Swifty service. And that because we've spoiled a lot of customers by this, and that's great. And so if you ever get into a bind that you need something like that, to please, please don't forget about that. Call us up, because we're going to make it for you. if we've got it on the shelf, we've got the raw materials, we're gonna do what we can to get you that product, because, you know, when a thermocouple goes down, you know, temperature is the most widely measured thing out there, and that if your process, your oven goes down, or you can't make whatever tire manufacturers can't do it, you know, you're stuck. You know, you're sitting there, you're wasting money, and a little $80 thermocouple works magic when it's up and running on that plant to keep it going. So we know how important it is, and that anyway. So please keep that in mind. Nick, I mean, you want anything else so I can hit on?
Sure, sure. Yeah. I just figured I'd open it up to any questions that anyone may have for Jamie. If you have any questions, hop on board.
Or if you're shy, you can put it down in the chat and I will read it to him.
Okay. Jamie, I have a question for you. I was just wanting to get your opinion on, for when you're sizing a Thermowell, what do you usually use as your parameter for deciding like the lagging length? Do you just go beyond whatever like insulation there is, like go an inch above, or is there other parameters you're looking at?
Well, I mean, it really depends on how much insulation you're going to be, if it's going to be insulation wrapped around the pipe, and that's a customer driven thing. I mean, the lag has nothing to do with the calculation itself. So that's just a customer preference. I mean, standard lags, like, you know, on standard U dimensions in the catalog, they come with, you can order them with a standard lag of like 3 inches. And let me see if I can go back real fast to kind of show you what, so like on a standard, like this right here, this sometimes can be confusing to folks, but you know, this shows a 2 1/4 inch plus T lag. And this is not really considered a lag. This is just your standard head connection. If you wanted, say, a 2 inch lag, then this is really going to be, this measure is going to be 4 1/4 inches long. So, you know, that's a customer driven thing. It just, you know, on flange wells, it's always going to be that 2 1/4 inch height. On standard, like a threaded well or a socket well, it's 1 3/4 inches. But, you know, that's, and you can also take into consideration, you may not need a lag, and then you just put a nipple union on your sensor to get you through the insulation. And also, you know, you be able to break that union where you're not as close to the well as you are. You may be above that insulation. Hopefully that answered that.
No, it did.
That's a great question. Thank you. So Jamie, there you go. Let's see. Are there any other questions anyone may have?
Yeah, I have a couple questions for you. First would be, do you have a preference or recommend a head type, like plug versus like a terminal block? I deal with both. You showed them at the beginning of the presentation, the quick connect plugs,
Right.
technical name, but we have that. And we also have a lot of the heads with the little fiberglass blocks. Is there a difference as far as measuring accuracy? Could you recommend one versus the other, or is it preference?
No, it's really, I mean, we changed that Phoenix terminal block is a great terminal block because it's a snap in, snap out, and you got your wires that plug into it. You just screw down. We did have our standard terminal block was I don't know if you've seen it, but it's like a 6V4 where you actually have to wrap the wires around and screw it. We still have that, but we've gone to all these where you just put in the wire and screw down, you know, tighten down the screw where it clamps down on it. Those are all brass plated, so there's accuracies you're not losing any accuracy either design you go, either which way you go.
Okay, thanks. And my second question is, with the Swifty Cow program, we replaced a lot of existing thermocouples. If I had a part number, could I input the part number and get a quote off of that, or do I need all the dimensions? Does that make sense?
You did a Swifty calculation.
I guess I'm asking for the ability to put in a part number and you guys reverse engineer it, or do I need to input all the dimensions myself?
Now, if you're doing a calculation on the well, the sensor will match up to the well, where you don't have to do that. You just pick out, J or K, or if you want to ground it, unground it, and it'll size the sensor to the thermocouple and give you that part number. Is that what you're talking about?
Yeah, I replace a lot of broken or existing, and so I have part numbers. I don't need to measure the length per se. I just need a new one that's exactly the same. Would I be?
Yeah,
And we could go ahead, Tom.
Jackson, so you're saying you've got an existing JMS thermocouple that you need, or RTD that you need to replace? Is that what?
Can I just input, or can I input that Swifty Cow, or would I be better off just calling you guys and saying, hey, I need this part? I mean, I didn't know if I would be able to utilize Swifty Cow for that or no.
No, you wouldn't need Swifty Cow for that. You can just call us up and,
There's
if you
a
have
work.
a tag, yeah, you can just call us up and give us that dimension. We can create your part number off of that. Or if you've
Okay.
got a tag number you associated with it off of Swifty Cow, or even if you didn't use Swifty Cow, if you've got if you've ordered from us before and you have a tag, we can search our account by that tag number,
Mhm.
and we'll find the original part number that way as well. So even if you don't, a lot of times guys didn't know what the part number was, so yes, to answer your question, you don't have to go back to Swifty Cow to do
Okay.
that. Just call
Okay.
us.
Thank you.
There's a work order number on there.
Yeah, on every one of our probes that we etch the date in the work order. There's a 6-digit number. And like right now, it's like 199 something. So if you see that 6-digit number, you can give that to the inside salesperson. They can pull that exact order right up.
Okay, thank you.
Yep, great question. Okay, any other questions, guys?
I got one more. Sorry to go with this is probably really rudimentary for you guys, but do you have like a preference as far as when it comes to the extension, like a nipple union nipple or a nipple union with a spring-loaded fitting? Is there an advantage to one or over the other? I haven't been able to really find anything that basically pro cons those two different designs.
Well, I always prefer the spring-loaded fitting with a union nipple on it, just because the spring-loaded half fitting actually has a kind of a guide bore for the tube to go inside of, and actually the spring is located inside that fitting. Unlike when you do a nipple union nipple, it's spring loaded against a terminal block or a transmitter kind of thing. So for me, I always try to push the spring loaded fitting in a union nipple. I mean, it still looks the same. It's not a spring loaded fitting acts as that other nipple on a nipple union nipple, but.
Okay, thank you.
Excellent. Any other questions?
And I'd also say for anybody out there who, in the next, until we, if you probably want to do this individually and things like that, we're here for the next, until we can start seeing folks. And so if you have anything like that, I'm available, and I'm sure Tom, Nick, and Bobby are as well via Zoom or Skype or whatever.
Yep, absolutely. Well, in fact, guys, I'll end. If there are no further questions, I'll